Guys, we are now going to work on the rest of this lab. This is the analysis and make a distance time graph. You should be able to do that from your knowledge of last week's. Consider the qualities of a good graph. You can do this on paper or on Google, but make sure to get that turned in. So calculate speed for each distance measured. Remember to show your work on another sheet of paper if necessary. So I am going to just do a couple of them down here. So my number 2, I need for 0 seconds, I need speed, distance, and time. Speed is my question mark, distance, 0 centimeters, time, 0 centimeters. Speed equals distance divided by time, 0 divided by 0 equals 0 centimeters per second. Write that up here. For 1 second, speed, distance, and time. Again, speed is question mark. My distance, 27.6 centimeters. My time is 1 second. Speed equals distance divided by time. 27.6 centimeters divided by 1 second equals 27.6 centimeters per second. Continuing on over here for 2 seconds. Speed, distance, and time. I've got my speed of question mark, my distance 105.4 centimeters, and my time 2 seconds. Speed equals distance divided by time. Plug it into my calculator. Speed equals 52.7 centimeters per second. I am going to go ahead and continue and do the others of the speeds. Step 3, make a speed versus time graph. Remembering to consider the qualities of a good graph. This is the new graph for the week. Time is still on the bottom. Our y-axis, though, is now the speed, so it's going to be that column on our y-axis. Number 4, calculate the acceleration for speed. Remember to show your work on another sheet of paper if necessary. Well, my piece of paper is full, so I'm going to find a stretch sheet of paper to continue to do my work on. So my acceleration at 0 seconds is my first item. So I need A, velocity final, velocity initial, and time. Well, for 0 seconds, we know we had no acceleration. So 0 centimeters per second squared. So I'm going to go ahead and do 1, so it's more valuable for your time. Acceleration is what I'm trying to find out. At 1 second, what was my final velocity? Final velocity was 27.6. My initial velocity, what was it just before that? 0 seconds, or 0 centimeters per second. And the time it took for that change is 1 second. So A equals VF minus VI over T. Plug in my variables, 27.6 centimeters per second minus 0 centimeters per second over 1 second. Plug that into my calculator, and I get 27.6 centimeters per second squared. Okay, first couple are easy. So now we need to go to 2 seconds. Okay, please note how I am taking the time to identify my variables. You guys should be doing that same thing through all of this work. Okay, acceleration is my question mark. Velocity final, 52.7. Velocity initial, where did I come from? Right here, this 27.6. And the time difference, the difference between 2 seconds and 1 second is 1 second. So A again, VF minus VI over T. Plug in my variables. Okay, I'm going to do this part first. So 52.7 minus 27.6 gives me 25.1. And now I divide that by my 1 second. And I get my acceleration being 25.1 centimeters per second squared. I am going to continue to do these, and that would be the end of those. So you should have all of this then filled out by the end. Okay, which of the two graphs shows the acceleration of car? Explain in detail why you picked this graph. Is it the graph from 1 or is it the graph from 3? Make sure explain in detail. Remember to give me evidence and your reasoning. Contrast the accelerations at the different points on this graph. Pick 3 spots to contrast. So, just for time's sake, this is my speed. I'm going to imagine my graph looks something like this. This might be A. This might be point B. Okay, and this might be C. So I'm going to talk about what happened in this segment, what happened in this segment, and what happened in that segment. You're going to have some definitive segments on your graph to make sure that you talk to me about. Name 2 specific things that could be done to change the acceleration of the car in this lab, and then make sure to tell me how that would change its acceleration. So name and what would happen. Okay, and then number 4, drawing lines on your acceleration graph to represent one specific thing you suggested in 3. So out of these 2 items that you suggested, I need you to come back to your graph and tell me how would that change the acceleration. Okay, so this is my change line. Okay. If you have any questions as you're doing this, remember Mrs. Farron is there, and you can always email me.